Hello friends, once again welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry. We were discussing unit 12 organic chemistry, some basic principles and techniques, and in this video we will discuss about IUPAC nomenclature of organic compounds having one functional group. When one functional group is present, the name of organic compound is written like this. First we will write the root word, that is number of carbon atoms present in the parent chain. Then we will add a primary suffix. If saturated compound is there, then we use ANE. If double bond is there, ENE. If triple bond is there, YNE. And then secondary suffix. This secondary suffix is characteristic for each functional group. Okay. First come to the class of organic compound alcohol. Its functional group is OH. Its secondary suffix is OL. It means when we write the name of alcohol in terms of IUPAC, then E of the parent alkane is replaced by OL. That is, we will write alkanol. For example, CH3OH. Okay. First of all, identify the functional group. This OH is the functional group, and there is one carbon atom is present. That's why this is methanol. Its common name is methyl alcohol. C2H5OH. This may also be written as CH3CH2OH. Its name is ethanol. In common system, this is written as ethyl alcohol. Now come to this CH3CH2CH2OH. OH means alcohol. 3 carbon atoms joined by a single bond. That's why first we'll write the prop, root word. Then AN, primary suffix. Then actually in this case, if you number the chain, then this carbon which is attached with the functional group is given the lowest number. Okay. And we will also write the position of that carbon to which functional group is attached. So this is 1 ol. Again remember, that is alphabet and number is separated by the hyphen. Clear? Now in this situation, again we give the numbering. Again remember, numbering start from the terminal carbon atom. You can give numbering from left hand side, then this is 1 2 3, and if you give the numbering from right hand side, then this is again 1 2 3. In both the cases, at the second carbon atom, OH group is attached. That's why this is propane 2-ol. Clear? Now write the name of this compound. First identify the functional group, that is OH. Then there are 4 carbon atoms. Okay. Then numbering will start from this 1 2 3 and 4. That's why this is butane 1-ol. Again remember, E of this butane is dropped. Clear? Now in this, numbering will start from this carbon atom 1 2 3 and 4. So this is butane 2-ol. Now this compound C double bond O, this is known as carbonyl group. Okay. Now in this case, this carbon of carbonyl group has 2 free valencies. If one valency is compulsory satisfied by hydrogen and another valency may be satisfied by hydrogen or R stands for alkyl group, then this class of compound will considered as aldehyde. Okay. But if both the valencies of this carbon of carbonyl group is satisfied by the alkyl group, then it is known as ketone. So first we'll come to the aldehyde. Its functional group can be written also this CHO, but actually this is the structural representation of this CHO. Okay, C double bond O and C single bond H, and this valency is free. This valency is satisfied by hydrogen or any alkyl group. Now again, when we give the numbering, then this carbon will also numbered. Okay, and this is also numbered 1 if only aldehyde is present. Its secondary suffix is Al. It means according to IUPAC, E of the parent alkane is replaced by Al, that is alkanal. Okay. First member HCHO. This is methanol, and commonly this is known as formaldehyde. Second member is CH3CHO. This is ethanol. That is, first identify the functional group. This is CHO, and also count this carbon of the CHO in the numbering. So this is 1, 2. 2 carbon atoms are there. That's why this is ethane. And functional group is CHO. That's why Al, ethanol. In common system, this is known as acetaldehyde. Okay. Then what can its name? Now in this case, you can expand this. This is CH3. And this is CH2 is coming for 2 times. That's why you can write this is CH2, this is CH2, and then this is CHO. Okay. So 4 carbon atoms, CHO, aldehyde functional group. That's why its name is butanol. This methanol, structurally it can also be written like this or this. Now come to ketone. Functional group is CO. This may be written like this one, or this one. Now in this case, the both free valencies of this carbon are satisfied by the alkyl group. Alkyl group is represented by R and R dash. Now this R and R dash may be same or different. Clear? Secondary suffix is O and E. Its IUPAC name. E of the parent alkane is replaced by O and E, and this is called alkanone. Now its first member contains 3 carbon atoms because both the valency of carbonyl carbon is satisfied by the alkyl group, and simplest alkyl group is CH3. So first member is CH3COCH3. IUPAC name is propanone. Common name is acetone, and this can also be written like this. Okay, when this is written like this, don't be confused that this carbon is also bonded to this oxygen. Okay, this oxygen is bonded with this carbon. Okay, only. Its second member, you can write this is CH3, CH2, CO, CH3, or you can also write this CH3, CO, CH2, CH3. Its name is butanone. Okay, now this one is, again, identify the functional group. This is CO. Okay, so this can, if you are confused, then you can also write this is CH3, CH2, this is CH2, then this is C double bond O. Clear? This is CH3. Now total number of carbon atoms are 5. Now in this case, we have to give the numbering to this chain. So this is 1, 2, 3, 4, and 5. 5 carbon atoms are there. That's why this is pentane. And second carbon is the ketonic group. So this is 2 on. Now in this case, you can, there is the CH3, CH2. The position of this CO may also be changed if there are 5 carbon atoms in a ketone. Then again, you can give the numbering from any side. You will get the at third position CO group is there. So this is pentane 3 on. Carboxylic acid. Functional group is COOH. But again, these 2 oxygen atoms are not bonded directly. Its structure is this. C double bond O, then single bond OH. This valency may be satisfied by hydrogen or any alkyl group. Its secondary suffix is oic acid. So its IUPAC name, E of the parent alkane is replaced by oic acid, that is alkanoic acid. If this valency is satisfied by hydrogen, then we will get its first member HCOOH. This is methanoic acid. Commonly this is known as formic acid, and this is the structure of this compound. Second member is CH3COOH, ethanoic acid. This is acetic acid commonly, and this is CH3COOH. Next, you can write this is CH3CH2COOH. Okay. Again, first identify the functional group. This is COOH, not only OH. Okay. This is COOH, and give first number to this. 1, 2, 3. That's why this is propanoic acid. Now this may also be written like this is CH3, CH2, CO2. Okay, it means this oxygen is twice. Then CH3, CH2, CH2, COH. This is butanoic acid. Now you can further condense this CH2 coming 2 times. That's why you can write this one. Nitriles. Functional group is C triple bond N. This may also be written as CN. this free valency of carbon is always satisfied by the alkyl group R. Secondary suffix is nitrile. But again remember, in this case, E of the parent alkane is not dropped. So we will write alkane nitrile. See, this is CH3CN. Now again this carbon is also counted in the root word. So this is 1, 2, ethane nitrile. This is CH3CH2CN. 3 carbon atoms are there including CN. That's why this is propane nitrile. This is butane nitrile. And this one is pentane nitrile. Esters. Functional group is COOR. But again, these two oxygen atoms are not bonded directly. This is its structure. Okay. Now this free valency may be satisfied by H or any alkyl group. Its secondary suffix is OAte. So we can write it alkyl alkanoate. Now again remember, R, that is alkyl group directly attached to oxygen, is written as alkyl in the name of this alkyl alkanoate. It means this R. Okay, so see, first member is HCOOCH3. So this is methyl. Okay, and one carbon atom is here. So this is methyl methanoate. Now again, this is CH3COO. If you write, this may also be written as CH3COO. So dear student, first of all, you must be able to identify the functional group. Okay, this one is ester. And this methyl group is attached with this oxygen directly. So this is written as methyl, and give the numbering this part 1, 2. So this is ethane, and OAte is the suffix. So this is methyl ethanoate. Now this one is CH3COO C2H5. This is ethyl, and this part is ethanoate. Now again, this is methyl. Now in this case, 3 carbon atoms are there. That's why this is propanoate. Acyl halides. Functional group is COX, where X may be halogen, FClBrI. Okay. Now this may also be written this COX. Now actually this is the derivative of carboxylic acid. In this carboxylic acid we are having COOH. So OH of carboxylic group is replaced by halogen. And free valency of this carbon is satisfied by either hydrogen or alkyl group. Its secondary suffix is oil halide. So in IUPAC name we can write alkanoyl halide. Okay. E of the parent alkane is replaced by oil halide. Come to the first member. This is HCOCl. This is methanoyl chloride. This one is CH3COBr. This is ethanoyl bromide. C2H5COCl. 3 carbon atoms are there. This is 1 and 2 carbon atoms in C2H5. That's why propanoyl chloride. Now in this case, this is acyl chloride. And how many carbon atoms total? This carbon is also counted in the numbering. This is 1 and these 2 in the form of CH2. 2 and 1 3, and this is 1 4. That's why this is butanoyl chloride. You can also expand this CH3 CH2 CH2 COCl. Acid anhydride. Its functional group is this. Free valency is satisfied by hydrogen or alkyl groups. Actually, it is formed by removal of water molecule from 2 molecules of carboxylic acid. Okay. Its secondary suffix is oic anhydride. So IUPAC name is alkanoic anhydride. Just see the one example. This is ethanoic acid. This is the another molecule of ethanoic acid. From 2 molecule of ethanoic acid, one hydrogen, the one water molecule is removed like this. So we will get this CH3COOCOCH3. Now this is obtained from the ethanoic acid, so its name is ethanoic anhydride. Clear? This can also be written like this, CH3CO twice O. If we expand it, this is CH3, then just a minute. You can write this CH3, this is C double bond O, then this is oxygen, then this is C double bond O, and this is CH3, ethanoic anhydride. But if this anhydride is formed by the two different acids, okay, like this is methanoic acid and this is ethanoic acid, then this water molecule is removed, then we will get this one. Then if we write the name of such anhydride, then the acid from which it is formed, the name of acid is written in the alphabetical order. So this is ethanoic acid and this is methanoic acid. So its name is ethanoic, methanoic anhydride. Okay. Amides. Functional group is CONH2. Again, this is the derivative of carboxylic acid. In this case, OH of the carboxylic group is replaced by NH2. So this is CONH2. Free valency is satisfied by hydrogen or alkyl group. Secondary suffix is amide. So this is alkanamide. E of parent alkane is replaced by amide. See example, HCONH2. Okay, this CONH2, this is the functional group, and this carbon is also counted. So this is methanamide. CH3CONH2, this is ethanamide. C2H5CONH2, total 3 carbon atoms including this CO. That's why this is propanamide. This is CH3CH2 2 times CONH2, total 4 carbon atoms like this, CH3CH2 CONH2. That's why this is butanamide. Amines, functional group is NH2. Free valency is satisfied by alkyl group. Actually, if this is amines are the derivative of ammonia. If free valency is satisfied by the hydrogen, then we will get the ammonia NH3. Okay, but this free valency is satisfied by alkyl group. Secondary suffix is amine, alkanamine. Okay, alkanamine. E of the parent alkane is replaced by amine. So first member is CH3NH2, methanamine. This is CH3CH2NH2. This is ethanamine. Now, if 3 or more carbon atoms are present, then NH2 may be present at the different position. So we have to give the numbering to lowest numbering to that carbon which bears NH2. So this is, we have to give number. This is 1, 2, and 3. That's why this is propane 1 amine. This may 1, 2, 3. That's why this is propane 2 amine. Now this is CH3CH2 twice CH2NH2. That is total 1 and 2. 2 carbon atoms are these, and this is 1. Total 4 carbon atoms. This one. That's why this is butane 1 amine. But this NH2 may be present at the second carbon atom like this. CH3, CH, CH2, CH3, and on this carbon atom NH2 group is present. So we will give numbering from this side. Lowest number to that carbon atom to which NH2 is attached. So this is butane 2 amine. Again remember, this E is not written here. Sulphonic acids. Functional group is SO3H. Free valency is satisfied by alkyl group. IUPAC name is alkyl sulphonic acid. See CH3 SO3H. This is methyl sulphonic acid. CH3CH2 SO3H. This is the ethyl part. So this is ethyl sulphonic acid. Clear? These are the functional groups whatever we have discussed, and these are written as a secondary suffix. But there are certain groups which are always written as a prefixes. Like this is OR, alkoxy, NO2, nitro, X, halogen. So if these groups are present, then we'll write their name like this. First we'll write the prefix, that is these one. Then root word, then primary suffix. Okay. Let us see some examples. First come to the ethers. This is free valency, then oxygen free valency. Okay, free valency is satisfied by alkyl group, so we can say this R, O, R dash. Now these R and R dash may be same or may be different. So its name is alkoxy alkane. If both alkyl groups are different, then smaller group is written as alkoxy. See the example. CH3COCH3. In this case, both these alkyl groups are same. So any one you can write as a methoxy, and this one is methane. Methoxy, methane. Now in this case, this is CH3OC2H5. Now this is smaller group and this is larger group. So this part is written as methoxy and this is ethane. Methoxy, ethane. Clear? Now in this case, this is methoxy and we have to give the numbering to this part. So at the first carbon atom, methoxy group is present. So that's why this is 1-methoxy propane. You can also write CH3, CH3. At the second carbon atom, OCH3 group is attached. Now again give the numbering 1, 2 and 3. Now this carbon atom is not involved in the numbering because this is not a part of this parent chain. Okay, so this is written as 2-methoxy propane. Nitro compounds. Functional group is NO2. Free valency is satisfied by alkyl group and it is again prefixed as a nitro. IUPAC name is nitroalkene. CH3NO2, this is nitromethane. C2H5NO2, this is nitroethane. This is CH3CH2CH2NO2. Now in this case, the position of NO2 may be changed. Now in this case, we have to give the numbering 1, 2 and 3. At the first position, NO2 group is present. That's why we will write 1-nitropropane. Okay. If NO2 group is present at the second position, like this 1, 2, 3, then its name is 2-nitropropane. Halides. Functional group is X halogen. FClBrI. Free valency is satisfied by alkyl group. So its prefix is halo. Okay. IUPAC name is haloalkane. Now CH3Cl, its name is chloromethane. Now in this, again the position of this Br may be changed, so we have give to the numbering 1, 2, 3. At the first position Br is attached, that's why this is 1-bromopropane. Now this Br may be at the second position, that's why this is 1, 2, 3. Its name is 2-bromopropane. Okay. Thank you. Subscribe my channel to get the next video from this chapter. In the next video, we will discuss the naming of organic compounds having polyfunctional group.